So today we are going to talk about the presence of zinc and its detrimental effect on blast furnace. As you must be knowing that as there is a more and more concentration of zinc in blast furnace, it creates a problem of Tuyer. And Tuyer started very sensitive in burning due to zinc, presence of zinc. And this zinc is basically coming into the blast furnace system with the help of input material, and it burned the tuyer, and which consequently create a lot of problem in continuation of the blast furnace process. As once tuyer burned, there is ingress of water in the blast furnace which create a manifold issues like the damages of the carbon bricks, reducing the campaign of the furnaces, generation of a newborn dual heart symptoms in the furnaces, production reduction, frequent stoppages, and so many things which are detrimental to the consistency of blast furnace process. Now coming to the sources of zinc, we need to recapture our source of zinc in from different inputs. As you can see that our measurely zinc percentage contributing from the recycled materials and center in particular. Now coming to the discussion and outcome of this presentation, where it has been shown that how this presence of zinc damages the 2 years has been taken from Handin steel, and based on the metallurgical microscope experiments, the outcome has been shared in this presentation. So as we can see, the first outcome of this research work is the grain structure. As you can see that in a new tuyer there is a uniform grain structure, whereas in the damaged tuyers it found that grain structure become bigger, and really from here only the problems start of tuyer damage. Now the second part which is contributing a lot is our alloy formation of copper and zinc. As in this slide it has illustrated that pure copper has got a very good conductivity, whereas as we keep on alloying copper with the zinc, then thermal conductivity start decreasing, and once it start decreasing, our heat concentration at several point becomes manifold, which becomes a responsible reason of tuyer burning in blast furnace. And here this has been illustrated in a splendid way that how the zinc ingress into copper surface and reduce the conductivity of copper. So this is a very good illustration where we can understand how the zinc diffuse into copper surface and reduce its conductivity. And this is basically a graphical representation where it shows that as percentage of zinc keep on increasing, our thermal conductivity go on decreasing. And this is how it has shown that as the zinc getting mix on the copper surface and the copper matrix due to reduction in the conductivity of the tuyer, heat concentration increases at a point, and it become one of the major reason of burning the tuyer by hindering is thermal conductivity potential. So in conclusion, we can say that with the presence of zinc, the grain size, number one, and number two is the alloying phenomena from zinc and copper, and consequently reduction of conductivity are the most important mechanism to damage the zinc. Thus, as a precaution, each operator or the blast furnace department must have to look into the recycled item is getting blended at sinter plant should be area of focus. It need to be very stringent and focused so that the load at the blast furnace end should be minimal and the damages to Tuyer should not be contributed by higher percentage of zinc. Thank you.